When you need several operations performed one after another, you put those operations into a function, and we've seen functions before throughout this entire course, because essentially we have a function called main, and this is the function that gets called when the program starts. So we've been using it throughout every single demo that I've done so far and every single demo that we'll do in the future, and inside we've also been calling other functions in order to give our demos. So let's talk more formally about what a function is. A function is essentially a block of code delimited by curly braces, which contains a couple of instructions which are actually done by the machine. Now, to invoke a function, you write down the function name, then you open the round bracket, and you put in any arguments that the function might take in between the round brackets. However, so far we haven't had functions return any values, we haven't had functions take parameters, so that's what we're going to talk about right now. So let's suppose, for example, that I want to print a particular value, so I'll have a function specifically for that. The function starts with the fn keyword, then you give the name of the function, like for example print value, and then we'll take an argument as the value that we're going to print. So we're going to say that this particular function, print value, is going to take an argument called x, and this x has the type i32, and let's actually implement this function. So this function is going to be fairly simple because we're simply going to print line value equals and then the value of x. And what we can do now is we can call this function. So to actually use this chunk of functionality, we're going to call this function by writing down its name. So it's print underscore value and then giving it the value of x. And you'll notice that instead of writing x comma and giving it a value, we can just provide the value like so. So we can say print value 33, put a semicolon in here, and let me make this a startup project, and then we'll run this. So set a startup project. I'm going to run this, and we're going to get our value equals 33. So what's happening here? Well, we get into function main, and function main calls this function called functions. That's our demo function. Inside functions, we call the print value function, and it's the print value function which takes an argument of 33, which goes on the stack, by the way. So 33 goes on the stack, we get into the function, and we actually print the value of x, which is in this case 33. It could be something else, we could change it. Now let's suppose that instead of just taking a value and printing it, we want to actually change the value. So let's imagine that we want, let's say we have a mutable value z with a value of 1, and we want to have some function that increases the value of z by 1. And what we do then is we effectively lend the function a reference to z for certain operations. So we allow the function to borrow the value, do something with it, and then release it and get back to us. So I'm going to define a function called increase, which takes an x, but this x is a mutable reference to an i32. So essentially we're borrowing this value, and then what we can do is we can follow the sort of dereference the reference. We can star x and increase it by 1. So here, if I want to increase z, I would just write amp z like so, and then let's print out the final value of z here, and let's run this. Okay, so a bit of a problem here. The z is mutable, but we're trying to pass it as an immutable. So let me put in a mutable modifier here, and let's run this again, and z has the value of 2. So what happened here is we declared a mutable value called z with a value of 1. We passed it as a mutable reference into a function called increase, and increase basically dereferenced the reference and increased the actual value by 1. So we ended up with a 2, and when we exited from the function, we changed the original value that we passed in, and that's exactly what we have printed out effectively. Now, so far we've had functions which simply did something. They did not themselves return values, but functions can actually give you back values. Like for example, let's do a simple one. Let's say you want to multiply two numbers. So I'll have a function called product which takes an x, and a y, and both of them are I32s. Now, if I want to return an I32, which is the product of these, I would define a return type, and I'll do this like this. You'll put an arrow, a single arrow, by the way, not a double arrow like you do in the match statement. So a single arrow, and you specify the return type, in this case also an I32. Now, to return from a function, you basically write a statement similar to the statement like this one. For example, with the one crucial difference, you do not put the semicolon at the end. So if I want to return the product of x and y, I just say x times y without putting a semicolon at the end, and this actually returns the value. So here what I can do is I can say let a equals 3, let b equals 5, for example, let p equals the product. So I'm calling the product of a and b in this case, but I'm also getting a return value from the product. So product will return to me the value of x times y, or the value of a times b, because that's what I passed as the arguments, and I save the result of the invocation of this function in a variable called p, which will actually also be of type I32, and actually print it out. So let's print line that. So this times this equals this, and we'll put a, b, and p in this location, and let's actually run this. Forgot the letter in here. Let's Control F5 it. So 3 times 5 equals 15. So this is the basic gist of how you use functions.